Hi there. I'm Phil Lamar, and I want to welcome you to NASA's Ask the Astronomers Live, the show where you get the opportunity to ask real astronomers your own questions as I talk to them about some of the most amazing things in the universe. Today, we're going to be discussing a planet seen a long, long time ago in a galaxy far, far away. Now, I know that's a pretty familiar trope in science fiction, but in science fact, this is actually the first time that astronomers have detected a planet in another galaxy so far away from our own Milky Way galaxy. So this is pretty incredible. I mean, 9 of those other kinds of planets, galaxies far, far away, only one here. Now, for those of you joining us on Facebook or YouTube, you can say hello in the chat or use it to send us your questions about this really amazing topic. And after we're done here, please be sure to visit our website, universeunplugged.org. There, you can watch all sorts of really cool astronomy videos and find out about upcoming episodes of our show and about other shows. Now, let me introduce you to our guests today, because they are going to give us some insight into how we are able to see a planet in another galaxy. Today, we're lucky enough to be joined by Roseanne DiStefano and Julia Bernson. Hi, Julia. Hi, Roseanne.
Hi, Phil.
Thank you guys so much for joining us. Roseanne, why don't we start with you? Can you please just say hello to the audience and tell us a little about yourself and the work you do?
Well, hi, everyone. I am an astronomer, and most of the work I do is actually theoretical, which means that people get data and, I and my colleagues try to figure out what it means. And sometimes that leads to new ideas and new theories. I've also been very lucky, though, to work on some observational projects. And the one that we're going to talk with you about today involves using data from the Chandra X-ray Observatory and the XMM Newton X-ray Observatory. So I just feel so lucky to do what I do. I love this work and I love doing research.
Nice. That's wonderful. Julia, how about you? A little about yourself and what you're up to?
Right. Well, hi everyone. I'm Julia. I'm a college student, so I'm not an astronomer the same sense as Roseanne. But I ended up starting to work with her because I did a high school summer project, and we found some pretty interesting things during that summer. And then have ended up working together for 3 years now. So I usually study physics, and now I've started to kind of enter astronomy as well.
Oh, interesting. Now, Roseanne, didn't you start in physics as well before going into astronomy?
That's exactly right. I did physics, and then at some point I decided, after I already had my PhD, I decided that the world of astronomy and astrophysics was just too good to pass up. And I decided to switch what I was doing.
Oh, wow. Oh, we've got a little hello from Ash Odinson. Says he's glad to be here for such a fascinating topic. Oh, Ash, you're not as glad as you're gonna be. Now, before we dig into the galaxies far, far away, tell us a little about the here and now. Have you guys got things that you're into or hobbies that have either you've done for a long time or have discovered in this strange last year and a half or so?
Right.
Hmm?
Well,
Julia?
I guess for myself, Julia, why don't you go on ahead?
No, so yeah, I mean, during the pandemic, I started picking up hiking. It was a great way to, not necessarily interact with a lot of people, but still doing something very nice and calming, getting a break from perhaps, a lot of Zoom studying. So yeah, so I picked up hiking and saw lots of nice mountains and places and doing so. So that's my quarantine hobby.
Okay, well that's a nice balance to sitting down and doing Zooms. It's like, okay, let me stretch the lower part of my body as well as my brain. Roseanne, how about yourself?
Well, just before the pandemic started, I had begun oil painting. And I'm not at all, I wasn't a childhood artist or a young artist, but I always had been fascinated by it. And I started painting, and the pandemic has given me, I guess, a little more freedom to indulge in that. And it's something that I very much enjoy. It seems to me that that creative process and the problem solving that you do as an artist is very similar to some of the things that we do as scientists. And I just love both of them.
Well, I can't imagine if you're oil painting that you're going to paint anything except that beautiful little creature on your lap. So she needs lots of black and lots of white paint.
Right.
Now, let's get to the meat of the topic. Now, you guys just put out a paper, correct?
Mm-hmm.
On this topic that we're discussing about you've announced the possible discovery of an exoplanet in another. Now, exoplanet is a term for a planet outside of our solar system.
Mm-hmm.
That's right.
Is that correct? So now you've discovered the possibility of an exoplanet in another galaxy, not just outside of our solar system. Can you tell me and everyone else exactly what that means, the significance of it?
Right. So what we do have, we stay on planet Earth, right? And we have our own star that we're orbiting around. And then our star is in a galaxy, the Milky Way, with about 100 billion other stars that may or may not have planets. And so what this discovery has done is then look at another galaxy. I think we have a video that illustrates this well, video 1, I believe. Right. So we that's our star. And then we zoom out and we can see that there are many, many other stars, and that they all form a galaxy. And then we looked at another galaxy, the Whirlpool galaxy, and it's about 300 million light years away. So we looked at that and potentially found a planet in that galaxy.
Mm-hmm.
Wow.
Now, perhaps something to point out in that image, I don't know if we can see it again, is that all of those yellow points corresponded to stars in our Milky Way galaxy that do have planets. So that's the sum of all of the planets that we know in the Milky Way. And now you can see the great distance of 30 million light years between the Milky Way and the very beautiful galaxy M51, which I think you may see in the background right now.
And Aislinn Barker said what I just said, wow. Because, I mean, looking at all of those stars, and as you said, the yellow ones are stars with, their own planet in orbit. So the distance between each of those is a solar system.
Right.
And now you put all of those together in the galaxy and then go 30 million light years away to another galaxy. How can you possibly end up? I mean, that's way too far away to just peek around the corner. How do you end up finding a planet in a galaxy that far away? Roseanne, how is that even possible?
I can try to describe that. Well, first of all, let me illustrate how far away it is. If we can see image 2, do you see that little cloud of stuff there in the middle? Mm-hmm. That's, if you're standing on the ground and you're looking, say, through a binoculars, that is an image of actually our galaxy, M51. And if you go to image number 4, you see what the galaxy looks like given the instruments that we have today to observe it with. So in the early times, people saw that tiny nebula, and there were some people as early as 1750 who wondered if that nebula and others that were scattered across the sky could possibly be galaxies like the Milky Way, island universes that might contain planets, perhaps similar to our own. And now if we go back again to image 4, you can see on the left-hand side is the optical image, which you would be able to take with optical telescopes. And on the right-hand side is the X-ray image. On the right-hand side, there are so many billions of stars mixed up together that it would be very difficult to study an individual star. But on the right-hand side, all of those points of light you see are individual X-ray sources, and we can study the light from each one. Even though we can't see it with our eyes, we can discover things by studying the light from those point sources.
Hmm. Okay. So narrowing the field from what's available visually to what's available in a different non-visual wavelength. Interesting.
Exactly.
And those are X-ray sources?
Well, there's special ones. Did you want to say a few things about X-ray binaries, Julia?
Right. So we're looking at X-rays as Rosanna has mentioned, and this is similar but also different from the kind of X-rays that you to look at a bone, for instance, if you've broken something. It's the same kind of lights that we're looking at, same kind of energy, but it comes about in very different ways. So, for instance, if you have a neutron star or black hole, which is kind of a dead star, you can call it, and then you put that in orbit with a star like ours, perhaps.
Mhm.
Then the star will start giving mass to this very, very heavy dead star. And so what happens then is that it gets very, very hot and very energetic. And because of this, then you start releasing X-rays, which is what that picture
Oh.
then shows.
Right.
Oh. Oh, so you're talking about binary stars. They're two stars together, one live, one dead or dying?
It's dead.
Well,
And
the neutron star or black hole is a dead star, which is the remnant
uh-huh.
of a massive star. And it's
Ah.
very, very small. So as
Oh.
mass from the donor star comes toward it, starts falling toward it, it picks up
Mhm.
immense amount of energy and starts to travel at speeds close to the speed of light. And it gets very, very hot. That's the part right in the middle there. It's very, very
Oh.
hot and it emits at X-ray wavelengths. And what you
I
just
see.
saw passing by, that kind of gives our whole story away because that little thing is the
Mhm.
planet passing in front of the X-ray source and temporarily blocking it. So that's really the core of our story. And
Oh,
that was
so
created by the
you're
Chandra X-ray
you're
Observatory.
you're picking up X-rays from the dead star, and then all of a sudden something blocks it?
Exactly. And this planet is big enough to block it. We actually thought of doing this because of some work that Nia Imara, a postdoctoral fellow at that time, now a faculty
Mhm.
member at Santa Cruz, she and I had some thoughts together that led to a paper that she led. And what we noticed is that even in very energetic X-ray binaries, the
Mhm.
region from which the X-ray emission comes can be very small. It can be
Ah.
so small that it's planet size. And that means that a planet like the one you just saw in the video can pass right in front of it and temporarily block it so
I
that we
see.
actually get a pretty big signal. We're looking at a source and suddenly it goes away and then it comes back again. So that's
I
the signal of the planet.
got it. And that's how you discovered that there was a planet in that other galaxy.
Exactly.
Oh. Was that a galaxy that we had seen before? Had we named it and everything?
Oh, sure. Julia, do you want
Yeah, no, absolutely, and it's a very well studied galaxy actually, and that was part of why our study worked out so well, because there exists a lot of so-called archival data. So NASA has these telescopes and other organizations as well that then observe the universe, and this data might be reserved for specific scientists for a short period of time, and then they're released to the public. So this currently exists online. So we actually just went on the internet, downloaded this data, and then we looked at all these observations and found this.
Oh, interesting. How long have we had the technology to pick up X-ray sources? Because Roseanne, you mentioned that people had this concept back in the 1700s. I'm
That's
guessing
right.
they couldn't pick up X-rays back then, right? Because
No, to
I've seen
see
pictures of their
X-rays, we
teeth.
have to go.
They
We
didn't
have to
have
go.
X-raying.
No. We did our teeth before we had X-ray astronomy. So to do X-ray astronomy, which means that you just simply looking, instead of looking for the optical light that comes from sources and stars, you're looking for the X-rays that they emit. And they only very energetic systems that are very hot emit a lot of X-rays. And
Mhm.
that's the X-ray binaries we're talking about. So we have to go over the into the atmosphere to see that. But interestingly enough, the technology that allowed us to do our work is based on the well, it went into designing the Chandra X-ray telescope and XMM Newton. Those were launched in 1999. So this
Oh,
data then accumulated over the years, and we used the equivalent of 10 days worth of observations spread out over about 15 years to be able to see or discover what we discovered. But that technology was there. We didn't have to invent new technology to do this.
fascinating. Now that you discovered this, what would a planet in a system like this be like? Do we have any? Does the data tell you what it would be like?
Tells us something. Did
Right.
you want to go into the size, Julia?
Right, I can mention. What we have been looking at this is there must be something that's roughly the size of Saturn, and so we can also show image one, and there we can see that we know that this must be in a so-called wide orbit. So we have the compact objects, the neutron star or the black hole, and then the companion star, which is the blue thing that we see in the picture. And so we have this mass, and we have the small X-ray emitting region, and then far out from that system, we then have a Saturn-sized object, most likely.
I see. Okay, got it.
Right, but then
And
right, Roseanne, perhaps you can add a bit on how nice it would be to live on this
Well,
planet.
it wouldn't be very nice to live there. But one of the things is I don't think we have to worry about any creatures or life there at this time because we think this is a very young system, probably
ah,
less than 20 million years old. And although that's a long time for human beings, in order for life to evolve on a planet, for it to develop and then evolve into complex forms, most likely takes much longer than that. So this
I
is
see.
a very young system, and the planet is likely itself very, very young.
Hmm.
It must have had a very interesting past because the compact object, the black hole or neutron star, may have supernovaed. And so this planet may have been
Oh,
around for that event. And in the future, the donor star of today is going to do something very interesting, which could include a supernova as well. And then the planet will either be ejected into space, or if it continues to be in orbit, it will be orbiting a binary composed possibly of two black holes, or a black hole and a
oh,
neutron star.
interesting. Okay, that's fascinating. Uh, one question I had is how close are the binary stars?
So,
They're close to each other. They're probably closer to each other than the Earth is to the sun.
Okay, got it. Oh, so that's very close.
Yeah.
And
Mhm.
the stars, the neutron stars that are X-ray sources, do those only exist in binary systems where there are two stars?
The ones that are very bright, when a
Hmm.
neutron star first forms after there's been a supernova, that
Right.
the thing that becomes the neutron star is the core of the old massive star, and it's still very
Right.
hot, but that will cool down gradually. So if you're very sensitive to X-rays, say in our own galaxy, we can actually detect at X-ray wavelengths some
Mhm.
neutron stars, some typically young neutron stars, and they're very dim. To be as bright as this X-ray source, M51 ULS1, you have to have mass being donated from something else.
That's why it's so bright. It's getting the energy from the other star, whereas a black hole that just is a supernova by itself wouldn't be as bright. Got it.
Right.
Okay.
Yeah.
Um, well, for those of you who are joining us late or just stepping in now, you're watching Ask the Astronomers Live. We know there's some nice folks who've said hello so far, and we're talking about the discovery of a planet around a binary star system in the galaxy M51, where one of the stars has died, but there still seems to be a Saturn-sized planet that orbits this system. Now, um, this is really exciting, and we've got some questions from our audience. Oh, there's a question from Ash. Um, oh, this is a good question. Was
Mhm.
this a focus study of this particular galaxy, or more of a wide range one encompassing multiple galaxies?
right. That's a very good question. So what we did was look at three different galaxies, and this was not because we thought that these three were more likely to have planets, but just because that was the data that we had and that we decided to look at. And so I think we looked at about 240 X-ray sources in those three galaxies. So that's 240 of these kind of systems. And then I think that included perhaps 2,600 data sets or something of the like. So there's more work to be done in this, that's for sure. There are more galaxies than three. So yeah, there's a lot more work to be done in the future.
Oh, interesting. That's fascinating. So you better hurry. How many years do you have till graduation?
Right, I have, yeah, a year and a half now. It's
Whoa, better hurry.
right.
Gotta find another planet.
Well, I think Julia, actually, it's an interesting story because very few people who start doing this kind of research in high school make as much, just stay with it long enough to make a discovery, much less to participate in something like this. I think we may have another high school student, Samarth Kumar from India, who is sort of following in Julia's footsteps and is now also participating in this type of search. So Julia has moved on to other projects right now, but we're always looking for people who can do some of this really fascinating work.
Well, maybe we've got some of them in our audience. Let's
That
see.
would be
Do we?
great.
Oh, we've got another question from Aislinn. Now, do you guys think we'll have new technology to visit other galaxies someday, or are we still a bit far from it? Oh, she's talking about not just seeing, but visiting.
Right, right.
Hmm.
Well, definitely, we're probably more than a bit far from it, because to do that, we would, if we wanted to get there ourselves, let's suppose you yourself wanted to see what was going on in another galaxy,
Mhm.
if you could travel at speeds extremely close to the speed of light, as you achieved that very high speed, for you, the distance between the Milky Way and that galaxy would seem to be small, and you would be able to get there in a reasonable time. But the problem would be if you wanted to come back, what you would find is that for us, time was going on as it did before, and it would still have taken you more than 30 million years to get there, and whatever time you stayed, and then 30 million years back. So you would come back, and I don't know if you would find human civilization on Earth. I hope so, but not the same people probably that you knew before when you left.
Ah, yes, the time-space problem.
Mm.
Interesting. Okay. And here's one from Slathrin. Oh, Slathrin wants to know, what are your thoughts on the Webb Space Telescope? That's the new James Webb Space Telescope that's going up soon. Do you think it could advance our knowledge in a way that could influence new technology, or would other avenues of research be better for that? That's okay. Do you guys have any thoughts on that? On what James Webb might do with this sort of work?
Right. So I think and Rosanna, do correct me if I'm wrong, but I don't think they observe in X-rays. Um, right. So I think for what we're doing in particular, perhaps not, but I'm sure it would be very exciting in many other regards.
Yeah, people are waiting with great anticipation for Webb because it's going to allow us to see very far back in the early universe. It's a wonderful time to begin this type of research. And it will be able to do some important work in the nearby universe as well, but it would not lead to this type of discovery. For this discovery, we relied on X-rays. There may be something in the future that comes up. Having new research always inspires new ideas. But although Webb will advance research in many ways, it probably will not play a major role in the type of discovery we're describing today.
Right, right. Because the James Webb Space Telescope is not working on X-ray wavelengths.
Mm-hmm.
Is that correct?
Right, exactly.
Ah, I see. I see. Now, this is another question that I was wondering, because Is the thing you've discovered definitely a planet, or could this be something other than a planet?
Right.
Since
So
since as you said, Aislinn, we haven't landed on it. We don't know for
And you
certain.
don't want to land there. Please don't go.
right. So yeah. So there are many reasons why we do think this is a planet. And for instance, we looked at many other explanations and looked at could it be this thing instead. And an example of those is, for instance, instead of what you have is you look at the X-ray light and you observe it for a period of time. You see that we have this amount of light coming in, this amount of light, and then suddenly you see that it drops and it disappears when the planet is blocking out the light, and then it goes back up again when the planet has passed by. And so, for instance, we're considering could the source just have turned off instead of something blocking light, and that, for instance, we were able to rule out for a number of reasons. And there are or perhaps you can go into more of the reasons why we decide this was a planet.
Yeah, I think an important thing, this is a great question, by the way, because it's as important as seeing that this data fits everything that it should if it is a planet that passed in front of the X-ray source. A crucial part of the research is to study every other possibility and to see if that possibility could be equally likely. So we did that. We probably spent more time studying the other possibilities. And what we found is that although, for example, it could be a cloud of gas and dust, if it were, the dip would have a different shape. And also, there would be some changes in the energy of the X-rays that we received as the X-ray source started to disappear and as it came back again. So we proved to ourselves that we could see that kind of change by looking at real dips due to clouds, at least that we think are due to clouds, and comparing it to what we saw here. And this one was different. It didn't show those energy shifts. And then you can ask, could it be another type of astronomical body? And only planets and white dwarfs actually have the right size to fit all of the possibilities for this system. And we could rule out white dwarfs for physical reasons. They would actually increase the amount of light we received rather than decrease it. And the other things are brown dwarfs, which are still not quite stars, but they're more massive than planets and a little bit different from planets. Or maybe even a tiny star, what we call an M dwarf. But these would not fit all across the distribution of possible sizes. And because this is a young system, the objects would be bigger than they are later on in their life. So they have a small probability of having caused this effect, but there's one explanation that fits everything, and that's the planet explanation. However, we call it a planet candidate for the reason that, we can't yet definitely rule out every possibility. We can simply say that they're not at all likely compared to the planet explanation.
Excellent. Oh, I love that. I love that. That you take the data, you come up with a theory, and then to prove your theory, you also work to disprove alternate theories. I love that. Quick, anybody, we're coming up on our end time. If there are any other questions you've got, put them in the chat there, and we can make sure that Julie and Roseanne can blow your mind with some more information. Here's one from Ash. Is this data going to inspire a change in how we look for exoplanets in general, or was this discovery the result of existing studies in X-ray emissions?
Right, so that's a great question, and I think that's one of the main points of this paper. This is a new method, and we really do hope that people will kind of change the way you can look at exoplanets as a result. Like it's very exciting because, I mean, we, as Roseanne mentioned earlier as well, like we are really jumping over a trajectory, and we started to look at things just in our own galaxy in optical light, but with this change in methodology, we can look even further away. So it'll be very exciting if more people get into this.
Right, and an interesting thing about it too is that we chose to look at other galaxies in part because that was so exciting. And also, as Julia had said, we happen to have some wonderful data sets. But you can do this in our own backyard as well. You can look at X-ray sources, and you can even look at dimmer X-ray sources nearby. So we hope that this method of using the X-rays will be more generally used. And who knows what kinds of discoveries that will lead to. What this does, though, is it is looking for planets around different kinds of systems from the
Oh,
ways that have been used to find the planets you saw in yellow on that first image, right?
got it.
Those methods will continue to be used. Ours will supplement what's already being done. And it's a useful supplement because, for example, the standard methods also have trouble with massive stars because massive stars are highly variable and it makes it hard to see the effects we usually like to use to find planets.
Oh,
In the X-rays, we're looking typically at binary systems that are or have been more massive. So it actually usefully adds to the knowledge that astronomers have been working to gain through the standard methods.
I see. Okay, so another arrow in the quiver. I love that.
That's a great way
That's
to think
great.
about it.
Oh, Slathern has another question. Is it possible that it? Oh, this is about the planet candidate. Is
Mhm.
it possible that it could be a particularly large rogue planet rather than one that is in orbit around that star? Oh, that's funny because I was just about to ask this question too. D- did the data that you guys were searching from show whether there was a time of orbit for
Oh,
the
good
exoplanet?
question. Mhm.
Right. So that was part of the things that why we had to work on this for a long period of time, work very hard on it, because we only see it once.
Right.
And what that indicated, we were able to say roughly how fast this object was moving, and we were able to kind of get a size. And from that, then we can get a rough estimate of how long it would take for it to return. And we said that that must be perhaps 70 years or longer. So that's a very long period. We
Oh,
have to look much further in the future.
Mhm. Mhm.
I got it.
Yeah.
So yeah, so because this is relatively new, still got some more data to get.
Right. Well, I think we're going to continue to look at many, many other systems, and very likely any new discoveries will be different from this one, and they'll
Right.
provide different kinds of information. So, I think what's really exciting about this is, first of all, that it's in another galaxy.
Right.
It's we knew that there were going to be planets there because it just made sense to think that they would be, but to have the first inkling through data that one is there is an exciting thing. But secondly, it's just looking ahead to all of the new discoveries that the community can now make in other
Right.
galaxies and in our own galaxy.
Wonderful, wonderful. Well, we're coming up on the end of our show, but before we go, I would like to ask: do you guys have any final thoughts that you want to share with the audience before we close out?
No, I mean,
Roseanne, Julia.
Mhm. Well, as I said, for us, this was an exciting journey. Doing this research was an exciting journey for the group. People often think today in science you need to have big groups. We were 7 people, and
Oh,
the technology that we used was technology that existed, but it sort of jumped over many of the difficulties that we would have looking for planets in a standard way. So it wasn't something that was on the horizon. It was a surprise in a way that we could do it, a surprise that Nia and I had first discovered. And then to actually try to look for them and to have success with this one system, all I can say is that it was very exciting, and it was a pleasure not only to do the research, but to work with our team.
wonderful.
right.
That's
No,
great.
and I can
Julia.
only reiterate that and say that also just joining this group, from a high school perspective, was an incredible experience, and just kind of showed me that there are a lot of people who are super willing to teach you and take time, even though might come in with not as much knowledge as they do. So if there are any high school students or college students that matter who are considering to go into this field, definitely try. And also for researchers to take on people who can grow into that role. It's been really a fantastic experience.
Wonderful. Thank you guys so much for joining us today and helping us understand this amazing new discovery.
Well, thank
And
you, Tim.
also,
This was a pleasure.
yes, thank you. And also want to thank all the folks who tuned in and who joined us in the chat. Ash, Aislinn, Slathrin, Alex, thank you guys for chiming in. It makes it so even more exciting.
It does.
Now, for the folks watching, you can see the video of this chat as well as all of our other videos at universeunplugged.org. Or just there's a link in the comments. You can click on that and go watch them now. But make sure you subscribe to Universe Unplugged, either on YouTube or follow us on Facebook, whichever you prefer. That way you can make sure you don't miss great conversations like this. All right. Thank you, Julia. Thank you, Roseanne. It was so great talking with you guys. And
Our
until
pleasure.
next time, thank you. I'm Phil Lamar, and this is Ask the Astronomers Live.